Prompt 2, they give us this beautiful graph of f. They define a function g of x as being 2x plus the integral from 0 to x of f of t dt. So we can't quite do our normal trick of just saying that this graph is going to be g prime because they threw this extra 2x in here to make it a more challenging problem. But that doesn't mean we can't handle this. We just breathe, we think. To find g of -3, we're going to go ahead and take -3 and replace every x we see with a -3. So 2x from the integral from 0 to x f of t dt becomes 2 times -3. Integral from 0 to -3 f of t dt. And then, of course, 2 times -3 gives us a -6. And then this is coming from the idea that we're going to integrate from 0 to -3. So this is presumably the area of a quarter circle whose radius is 3. And it's negative because even though the graph is above the y-axis, we've gone from 0 to -3, moving in a negative direction. So 9 pi would be the area of the entire circle, but of course we only have a fourth of it. So g of -3, 1 point for recognizing that it's going to be this. The second point is to find g prime. So we'll just take this guy's derivative. And of course the derivative of 2x is simply 2. And then this derivative is simply going to be f of x. So 1 point for recognizing that g prime is going to be 2 plus simply f of x itself. And then a third point for taking whatever answer you got from this part and plugging -3 in there. So if you have this wrong, but you plug -3 into it, you'd still get that point. As it is, if this is correct and I plug in -3, I'm going to get 2 plus f of -3. So now I've got to look at my function and figure out the y value when x is -3. That's this point right here. And I can see that when x is -3, the y value of this function is 0. So it ends up being 2 plus 0, or just 2.